Next, we're going to talk about the square root property. So if u is an algebraic expression and d is a positive real number, then u squared equals d has exactly two solutions, the positive square root of d and the negative square root of d. This can also be written u equals plus or minus the square root of d. And we can use this to solve some quadratic functions. This is just another tool to have in your toolbox. So let's work through a couple examples. If I have f of x equals x squared minus 12, 12 isn't a perfect square, so I know this isn't the product of a sum and a difference. If I set it equal to 0, and I move the constant to the other side, I have x squared equals 12. So I can take the square root of both sides. That would give me x equals plus or minus the square root of 12. Well, I can simplify the square root of 12. Remember, the square root of 12 is really the square root of 4 times 3, so that becomes 2 square root of 3. If you aren't quite sure how to simplify radicals, send me an email and I'll give you a link to another video on my YouTube. So x equals plus or minus 2 square root of 3. So now I have two solutions, right? X is 2 square root of 3 and x is negative 2 square root of 3. But I've got two irrational solutions, and that's okay, right? Irrational numbers are real numbers. We can graph them on the number line. For this second example, I have f of x equals x minus 2 squared minus 16. We're going to go ahead and set this equal to 0. Let's move the 16 to the other side. I'm going to go ahead and take the square root of both sides, and I can do that, right? Because I have x minus 2 squared. That gives me x minus 2 equals plus or minus 4, because the square root of 16 is 4. So I have x minus 2 is 4, and x minus 2 is negative 4. And now I can solve for my two x-intercepts. So I have x equals, we add 2 to both sides, I have x equals 6. I add 2 to both sides, I have x equals negative 2. So that's how we use the square root method to solve quadratic functions. The next method is completing the square. This is everybody's least favorite method of solving a quadratic function. I'm going to show you how to use it so you have it in your toolbox. But remember, we're in pre-calc now. We aren't in college algebra. So as long as you know how to solve a quadratic function, I do not care which way you solve it. Sometimes I think that factoring or completing the square is faster, at least for me, than using the quadratic formula. The quadratic formula is kind of clunky. It's something you have to memorize. And you have to be really careful with your negatives or if you make any kind of mathematical error. Now, I am very forgiving, but the homework is not. You have to have the exact answers. So just keep that in mind as we go through this section. Completing a square allows you to use the square root property. So if I have x squared plus bx as a binomial, if I add b over 2 squared to both sides, well, right now just to one side, a perfect square trinomial will result. So let me show you how this works. So if I have x squared plus 8x, and I add 8 over 2 squared, that's going to give me x squared plus 8x plus 16. And that's going to factor perfectly if I found the factors of AC that added up to B. That's going to factor perfectly to x plus 4 squared. So what we're doing is we're allowing us to build up to use the square root property. First thing I wanted us to get used to was knowing what constant to add to our A and B terms to complete the square, and we'll use that to solve a quadratic equation in the next slide. If I have x squared minus 4x, minus 14x, I'm going to add, keep your negative, it's going to cancel out, but keep it, negative 14 over 2 squared. That gives me x squared minus 14x plus 49. See how we factor to x plus b over 2 squared? Well, b over 2 would be negative 7. So I have x minus 7 squared. That's how we'd factor these. Now let's go ahead and solve a couple quadratic functions. So How do I solve by completing the square? So first, I set my function equal to 0. Second, I make sure my leading coefficient a is 1. Otherwise, this isn't going to work. It's not going to work. So I'd have to divide both sides by a in order to eliminate that a coefficient. Next, I am going to rewrite the equation so my constant term is a load on one side of the equality symbol, i.e. we're going to move that 10 to the other side. Next, we add b over 2 squared, not just to one side, but to the other. Remember, we have an equality here. We have an equation. And what we do to one side, I need to do the other. So I'm going to add 8 divided by 2 squared to both sides. So I get x, I don't know why I did that parenthesis. Oh, right, that doesn't erase. Oops. So I have, let's try that again, x squared plus 8x plus 16 equals negative 10 plus 16. That's going to add up to 6. This is going to factor to x plus 4 squared. Now I can use the square root property in order to solve this quadratic function. This gives me x plus 4 equals plus or minus the square root of 6. So I have x plus 4 equals the square root of 6, and x plus 4 equals negative square root of 6. So x equals negative 4 plus square root of 6, or x equals negative 4 minus square root of 6. Those are my two x-intercepts, my two solutions. Notice again that they are radical, but that's not always going to be the case when I use completing the square. So let's solve these other two quadratic functions by completing the square. We set our function equal to 0. We move our constant to the other side. We add our middle term divided by 2 squared to both sides. This is going to factor to x plus 5 halves squared. I've got 1 plus 29 fourths. Nope, 25 fourths. I skipped a step. That's going to be 29 fourths because 1 is 4 over 4. And in order to add fractions, they have to have a common denominator. X plus 5 halves squared. We take the square root of both sides. I get x plus 5 halves equals the square root of 29 over the square root of 4, which is 2, plus or minus. Then we can go ahead and say x equals negative 5 halves plus or minus the square root of 29 over 2. And if I wanted to, I could rewrite that as one fraction. And those are my two x-intercepts. For problem 2, I have f of x equals 2x squared minus 4x minus 5. Notice that my leading term is not a 1, so I'm going to have to go ahead and divide everything by 2. So I get x squared minus 2x minus 5 halves equals 0. Then I'm going to go ahead and move my constant to the other side. And I add 2 divided by 2 squared, negative 2 divided by 2 squared to both sides. This is going to factor to x minus 1 squared equals 5 halves plus 1, which is 7 halves. So I have x minus 1 square root of 7 halves. We take the square root of both sides. X minus 1 equals plus or minus the square root of 7 over the square root of 2. I'm going to go ahead and add 1 to both sides. So I get x equals 1 plus or minus the square root of 7 over the square root of 2. Now we need to talk about something. We do not like radicals in our denominators. So let's rationalize. It's called rationalize. Let's rationalize this radical. So I've got 1 plus or minus the square root of 7 over 2. Let's switch to green because it's easier to see. So I have x equals 1 plus or minus the square root of 7 over the square root of 2. So first off, we want to combine this to be one fraction. So I have x equals the square root of 2 plus or minus the square root of 7 over the square root of 2. I'm going to go ahead and multiply by the conjugate of our denominator, which in this case is just the square root of 2. And I do this because it's going to rationalize my denominator. Rationalize, right? We're going to make it a rational number, not an irrational number. So I get x equals square root of 2 times the square root of 2, which is 2, plus or minus the square root of 7 times the square root of 2, which is square root of 14 all over 2. And that should be our final answer. Those are our x-intercepts. Make sure you rationalize your denominators.